So Energy Part 4, the Energy Resources lesson. As usual, this pack is starting with a checklist, so I'll just remind you at this stage, if you go back to the previous Part 3 pack, look at the checklist there and make sure you've RAG rated to see which parts you're confident about in the previous pack, the previous part, before moving on to this part. As usual, there are the key facts that are listed on page 2 and the main things that you need to be able to do. So you should be able to find out, these are the things I need to know, these are things I should be able to do after I've been through this lesson. So we're going to start off, and we can see that what we're trying to do is to understand the uses and limitations of a variety of energy resources. And it says here that an energy resource is something that can produce heat, power, life, move objects, or produce electricity. So this is something that we use, and you'll hear about it spoken about on the news in terms of the types of energy resource we're trying to use, particularly with relation to climate change. So the first thing you needed to do was list as many energy resources as you can. So there's essentially two types of energy resources, and they are listed in your revision guide. And there's two types, so there's non-renewable and there's the renewables. And we'll see what these words mean exactly a little bit later on. So we've got the non-renewables and the renewables. And we've got a lot of different types of energy resources that we can use. So on the non-renewables, we've got coal, oil and natural gas. Renewables, amongst others, we have solar energy from the sun, wind, wave, tidal, biofuel, geothermal, hydroelectric. So we've got a lot more choice, it seems, in terms of the renewables than in the non-renewables. So the next question I asked is, which energy source do you think supplies most of the UK's electricity? So we can look at the use of these energy resources, both overall, how much is used, and then how much is used to produce electricity. So this chart, it shows the energy resources used in the UK. On the left we've got for 1990, and on the right we've got for 2017. The big red box at the bottom, that's for oil, with a yellow box for gas, then green for coal, and then the light blue is nuclear energy, and then we've got bioenergy and waste, energy generated from waste. So what we see is that the big change is that gas use has massively increased, whereas use of coal has massively decreased. The use of nuclear has pretty much stayed pretty much the same. And then we have this new one coming in 2017, the bioenergy and waste, which didn't really appear very much in 1990. So this chart appeared in your PowerPoint, and it shows where the UK electricity comes from in 2016. And what we see is that most of the electricity that in the UK was generated from gas. So most is generated using non-renewable resource gas, some coal, which is the black one at 9%, and nuclear power, which is another non-renewable energy resource. So in response to this question, which energy resource do you think supplies most of the UK's electricity? Most of the UK's electricity comes from non-renewable sources such as gas. In this next task then, we have to fill in the missing words. So again, you can use the notes from the PowerPoint or in your revision guide to help you find these words that are missing. You can pause the video. I'm now going to fill in the missing words as I think they should be. So here are my answers for these questions. So what are they used for? Energy resources are used to generate electricity for transport and to heat homes. Non-renewable resources, the main difference between a non-renewable resource and a renewable resource is that non-renewables will eventually run out. That's the big difference. Also, they all damage the environment in some way, but provide most of the energy for the UK. Non-renewable energy resources include the fossil fuels, and the fossil fuels are coal, oil and natural gas. So these are the fossil fuels. There is also a fourth non-renewable energy resource, which is nuclear energy, which is not a fossil fuel. Renewable energy resources are renewed as they are used, so they do not run out. So renewables do not run out, non-renewables will run out. Some can still cause damage, particularly to the local environment. They do not provide as much energy as non-renewable energy resources, and some of them are unreliable because they depend on the weather. And then we have these ones that you may already have had in the list above. These include solar, wind, wave, hydroelectric, geothermal and tidal, as well as a big one, as we saw from the graph that we saw about use of energy resources in the UK, something called biofuels. So you can pause the video if you want to take a closer look at those words to make sure you have them correct. So again, you'll find the words needed to complete these, to understand what these things mean, the missing words. You'll find this in your revision guide or in the PowerPoint. The first part is really for you to try to recall what was on the previous page. So it's useful to try and answer this one without looking back. Energy resources are used to generate, and if we remember, that was electricity for transport and to heat homes. So transport, something and something are used in most cars. Well, most cars still currently use either petrol or diesel, although electric cars are now becoming much more popular, but that's still those are the two main fuels. Coal was used in old-fashioned steam trains. This was when coal was mostly used in the 19th century for old-fashioned steam trains. Some newer cars, they can run on biofuels or run directly on electricity, which require then charging. Heating, most homes in the UK in any case have gas boilers, and that burns gas, and it's called natural gas. Some homes also contain fireplaces where wood or coal may be burned. Then we have, in some countries, very fortunate countries like Iceland, they are able to use something called geothermal pumps. What happens is that the water is pumped underground, and underground the temperature is very warm. These are countries that have a lot of volcanic activity, for example, and that will provide heating that way. Also, solar, as well as being used to generate electricity, solar water heaters can be used to heat the water that's then pumped into radiators. And again, we can also use biofuels. So these are options instead of using a gas boiler, although a gas boiler is still the most typical thing used in homes in the UK. In the next part, it talks about trends in energy use. Now, trends means how are things changing over time? So what's happening with the use of our energy? Is it going up or is it going down? Are we changing which energy resources we're using? This is what we mean by talking about the trends. So again, once I've completed this, you can pause the video so that you can check that you have the correct words. Okay, so once I've explained this, you can pause the video to make sure that you've understood the points. So the first point is the total amount of energy used in the world is increasing as the population increases and each person is using more energy. Now, in a way, we have to realize that this is actually not a bad thing. This is, in some senses, a good thing. So I'm just going to show you some graphs that show this. So again, these are in your PowerPoint. We've got this graph, and what this is showing is along the x-axis, we've got years starting from 1965, where we can hardly see any of the renewable energy resources being used, and the energy required going up over time when we get up to 2013 over on the right hand side. So we've got a massive increase in both the total amount of energy, but also in terms of renewables. If we look at this in a little bit more detail, so here we have each of the different types of energy resources. So at the top we have the three types of fossil fuel energies. That's basically oil, coal and natural gas. So those are those three lines at the top here. At the bottom we have the main renewables, so that's primarily hydroelectric, and the green line with the other renewables, and we can see this increasing quite rapidly, the green line with the other renewables, and the red one that looks fairly flat, that is for nuclear power. But what we see is all of these lines, apart perhaps from the nuclear, are pretty much going up as the population of the world increases. Now, I've said, now this is a fact. The amount of energy used is increasing as the population increases. But as I said as well, I personally, and this is not something you'll be asked about in your GCSE, this is quite a good thing, because obviously it's a good thing that more people are surviving around the world. And also it says each person is using more energy, and that's happening because poorer countries are becoming more wealthy, more people are living in better circumstances, which means they end up using more energy. So this is, although there are implications for climate change, this in a sense is a fact that it is increasing, and that it tells us something positive about humanity and the way that people are living. The second thing we should see is that renewable energies make up about 20% of total energy consumption, and at the moment it appears that this trend is unlikely to change until after 2035. So we still will have non-renewable fossil fuels particularly with us for some considerable period of time. Now the reason why this is because when a country is thinking about using renewable energy resources, they have to consider three issues. They have to consider the security of supply. They have to consider, will we still be able to get our energy resource to generate our electricity next week, next month, next year. The second thing they need to think about is reliability of supply. Once we're using it, does it give us the electricity we need, or does the amount of energy released go up and down? And then the third thing is we need to consider the sort of political and ethical issues. So for the first one, we can say that fossil fuels provide a continuous supply of energy, but global politics can impact the security of supply. So for example, if there was a major war again in the Middle East, a region where there is a lot of oil production, then potentially that could affect the supply of fossil fuels that are used to generate electricity in the UK. With something like wind or solar power, they're much easier for us to get access to. So we just need to install some solar panels. It doesn't matter what happens elsewhere in the world and politically or in terms of any sort of conflicts. We'll still get our solar power working, but the problem is that it does depend on the weather. So the amount of energy that we get released as electricity goes up and down. It's unreliable. And then the thing is that we have to take it always into consideration that the amount of these fossil fuels always decreases as we use it. They will run out. So an increase in renewables is likely, given that these are going to run out. And again, you can pause the video if you want to check the words and make sure you have the correct words. Now, in the next task, you had to use all the slides of information that you had in the PowerPoint, as well as information you would find in your revision guide, to try and complete these tables of information. So what I'm going to do is I am going to complete these so that you have the model example that I will put on the video, and then you can pause it to look and see what's written in there to make sure that your table has got all the information that you need. So for the first page, where we have solar, wind, geothermal, tidal and wave energy, these are all forms of renewable energy, although where the energy comes from is different in each case. So for solar energy, it comes from sunlight. Wind energy comes from wind. Geothermal comes from underground heat, and that's in volcanic areas, and it's coming from radioactive material underground, mostly. Tidal energy is also renewable, and it's coming from the tides, and the tides are generated by the gravitational pull of the sun or the moon. So the tidal energy is essentially coming from the gravity of the sun and the moon. And wave energy is coming from waves on the sea. That's generated through the wind. So if we look at how these work, we have solar energy, and what we have are what's called solar cells, which are circuits that generate electricity or electric currents from sunlight. Wind energy works with wind turbines, and the wind turbine has got a generator inside, and that's turned by the wind, and it generates electricity. The geothermal, this is where there's underground heat, and water or steam is pumped underground to be heated or to generate electricity. The tides are used with what's called a tidal barrage, which is like a big dam that's put in river estuaries, and river estuaries are where rivers meet the sea. And then finally we've got wave energy, and wave energy comes from lots of little wave turbines around the coast that generate electricity. So what are the advantages of these? Well, for solar energy, the big advantage, and this is an advantage of all of these renewable energy resources, I should say, is that there is no release of carbon dioxide, so it does not cause global warming. This is the big advantage of these renewable energy resources. Solar energy, it also has the advantage of having very low running costs. Once it's built, it's very low to keep it working, and it's not generating any pollution of the atmosphere. However, the disadvantages of solar are the initial costs are very high. It can be unreliable if it's a very cloudy day, particularly a problem in the UK. It only works in the daytime, and we can't increase the power output if the demand suddenly goes up. For wind energy, very similar advantages: no CO2, so it doesn't contribute to global warming. There's no pollution of the atmosphere. It doesn't produce any dangerous gases, for example. No fuel is needed once it's up and running, so very low running costs. However, like solar, there's very high initial costs, and it can cause noise and visual pollution. That is, many people find that wind turbines, they spoil the view, and they can be very noisy. They're unreliable if the wind is too weak or too strong. Like with solar, we can't increase the power output if we need more energy. The geothermal, like the others, no contribution to global warming. They're actually very reliable. Once they're built, it's free energy and there's little environment damage. So geothermal, in some ways, is almost an ideal energy resource. Its disadvantage is high initial costs, but the real big disadvantage is obviously it depends on the area. So it needs to be built in typically a volcanic area. So there's very few suitable locations in the world for geothermal energy. Next we had the tidal energy generated through the tidal barrages. Again, no contribution to global warming. It's reliable in that the tides always happen twice a day. There's no pollution of the atmosphere once again. No fuel involved, so no low running costs. It's moderately high initial cost to build the tidal dams. Lower tides, so sometimes the tide can be a bit lower, so that will reduce the power output. And again, it's only used in certain locations, so it's built typically in river estuaries. Then we have wave, so wave energy from the little wave turbines all around the coast. Again, no contribution to global warming, no pollution of the atmosphere with gases, and minimal running costs when built. Disadvantages: high initial costs, like the others. It's unreliable as the amount of energy generated can drop, as if the waves are small because there's less wind, then we're getting less energy out. And they can damage the seabed, and they can be a hazard to sea life and to boats. So what you need to do is you need to now pause the video, make sure you can check what you've written against what's written here, so that you can add to your table. And this is the minimum information that you need. So these are the first 3 columns, and then these are the last 2 columns, so you can pause the video and check your answers. Now for the next page, we have 2 renewables, that's hydroelectric and biofuel, and 1 non-renewable, which are the fossil fuels. So hydroelectric, where is that coming from? Well, the energy is coming from water that's flowing down a hill. Biofuels, it's generated from fuel that's come from plants, or it's come from animal waste. And fossil fuels, well, this is coal, oil and gas, and these are extracted from the earth. So how do they work? Well, the hydroelectric, so it's water flowing down a hill. What they do is, up on a hill, they flood a valley that's at the top of a hill using a dam, and then they let water flow through the dam in a controlled way through turbines that then generate electricity. For the biofuel is burned, so whatever fuel we've got from these plants or animal waste, that's then burned to generate electricity. So it works like fossil fuels. However, biofuels can be carbon neutral if, for example, you are replacing the plants that are being used to produce the biofuel. And then fossil fuels, it's very straightforward. The fuel is dug from the ground, it's refined, and then it's burned to generate electricity or to provide heat. What are the advantages of these? Well, looking at hydroelectric, first of all, so this is the water flowing down a hill through a dam. You can increase the amount of power output if you need to. I should add here, once again, there's no contribution to global warming because it's not producing CO2. They are reliable, and there is minimal running costs once it's up and built, and there's no pollution of atmosphere with dangerous chemicals or molecules. What are the disadvantages? Well, it's very high initial costs typically, and there can be a big impact on the environment. It will destroy the local habitat, and also it obviously can only be built in certain locations. The biofuels, the advantages, well, we say carbon neutral. It does release CO2, so that contributes to global warming, but then by growing plants, the CO2 is then removed from the atmosphere by the plants. So overall, the idea is that there is no CO2 increase overall. It's fairly reliable. You can you generate it the same way as with fossil fuels, by burning the fuels. So it is reliable if you're able to store the biofuel. And again, you can increase the output if you needed, but again, if you've got some biofuel stored, so you can burn more of it. Disadvantages: high cost to set up. It uses water and space that would otherwise be used for example, growing crops for food. And use of the increase in biofuels has led to forests being cleared, which has damaged habitats. So biofuels, there is the argument that they're carbon neutral, but this is something that's still argued about, whether they are truly carbon neutral. Then finally, fossil fuels. Well, what's their advantage? Well, they're very reliable. There's enough fuel available in the earth to meet the demands that we have at the moment. And once it's up and running, the running costs are relatively moderate. What are the disadvantages? The big one is releases CO2, so that causes global warming. So that's the big problem. There's high setup costs building these power plants. Another problem is they do produce pollution such as sulfur dioxide into the atmosphere, and that causes acid rain. And furthermore, when the fuel is extracted and transported, that can damage the environment, which is seen when, for example, oil tankers sink and oil is spilled onto the sea surface. And the other big disadvantage, of course, is that the fuels are running out, so eventually there will not be enough fossil fuels. So once again, pause the video, make sure that you've had a chance to check what you've written and to add anything that's missing from your table. So here are the first 3 columns, and then the last 2 columns. And then we have the last fuel. This is the nuclear energy resource. It's non-renewable. It comes from using nuclear fuel. This is either uranium or plutonium that's dug out of the earth, like oil, coal and gas. This fuel is then used for nuclear reactions happening inside a nuclear power plant that's used to generate either heat or electricity. The advantage of nuclear is it's very reliable, like fossil fuel. There's enough of the fuel for us to meet our demands for now. So it's very similar to using fossil fuels, but the big advantage of nuclear is that it does not release CO2, so it does not cause global warming. There's moderate running costs, and if we need to increase the power output, we can. We just need to increase the rate of the nuclear reaction. So it has the same advantages as fossil fuel, but it has an additional advantage in that it does not contribute to global warming. The disadvantages of nuclear is that it's very high initial setup costs, but particularly final decommissioning costs are very high. So this is when a power plant is gradually comes to the end of its life, it stops working. It's very expensive dealing with all the radioactive waste safely. The second big disadvantage is that there is a risk of an accident happening which can cause a major catastrophe, which was seen in Fukushima in Japan and Chernobyl in Ukraine. So once again, pause the video, check your table. And then the advantages and disadvantages.